Alright, so this question says circle D intersects the center of circle E, and then circle E intersects the center of circle D. The radius of each circle is 6 centimeters, and then we're trying to find the area of the shaded region where both of those circles overlap, and it can be expressed as a pi plus b root c centimeters squared. So honestly, I think this is one of the most challenging, if not the most challenging question on any of the handouts so far, because it is pretty complex. But in any way, let's just get into it. And so first we're going to have to break this down. And so we noticed that this figure right here, this picture, it's symmetrical over this line right here. So if we were to find the area of this part right here, that's half the shaded region, we could just double it to find the area of the entire shaded region. So how do we find the area of, half of the shaded region? Look guys, I've upgraded. I can draw good circles now. Just kidding, I didn't draw it. Basically, what we're going to do is we're going to find the area of this sector right there, and then from that sector, we're going to subtract the area of this triangle, and once we do that, we'll be left with this area, which is half of the shaded region in the full illustration. So that's going to be the area of the sector minus the area of the triangle multiplied by 2. So that will give us our final answer. So how do we find the area of the sector? Well, we know that the sector's area is going to be a fraction of the entire circle's area, but what fraction? Well, we first need to find out what angle this is, right? Because the fraction of the entire area that the sector will be is just going to be the angle theta, let's call this theta, divided by 360, theta out of 360, because the entire circle has 360 degrees. And so that's going to be multiplied by the area of the entire circle, which is pi times r squared. And we do know that r is going to be 6, because it says it in the problem. But I'm just going to write pi r squared for now. So knowing that r is 6, well, it doesn't tell us what angle theta is, but can we somehow figure it out? Well, for this question, we're going to have to realize that, like it says in the question, D intersects the center of circle E. And so this figure, like I mentioned earlier, is symmetrical. So what is the significance of that? Well, basically, if this right here, this is also the radius, because it's going from D to, all the way to the end of this, that's the radius of 6. And so we can cut this in half to say, well, to get from D to the start of here, so from D to here, that's going to be 3. It's just going to be half of 6. This right here is 3. So if this is 3 and that's 6, well, how does that help us figure out what the angle is? Well, another thing we know is that this right here, the intersection between, that radius and the line we've drawn that goes halfway through the shaded region, well, this forms a right angle. They're perpendicular. And so if this is a right triangle, we know that there's a type of special right triangle where, there's a side opposite the 30-degree angle, which is x, the hypotenuse, or the side opposite the 90-degree angle is 2x, and then the side opposite the 60-degree angle is x root 3. So if this is our right triangle, and we know that this is 6 and this is 3, well, this is a 30, 60, 90 special right triangle, because again, the hypotenuse is 2x, 6, and then this leg is half of that, which means that this must be the 30-degree angle, and this right here must be the 60-degree angle. So that means theta, because theta is this angle twice, it's double this angle because there are two triangles, theta is equal to 120 degrees. So we know that the area of this entire sector is going to be theta over 360, which is, again, 120 over 360, which is 1/3, times pi r squared, and r squared, well, r is 6, that's 6 squared. And so now we just have to find the area of this triangle, because that's what we're subtracting. So like we said before, this is a 30, 60, 90 degree triangle. And so if we have that x is equal to 3, and then the 2x is of course 6, well, that means this length right here, that's going to be x root 3. So it's going to be 3 root 3. So this is the entire base of this whole triangle. And so we know half the base is 3 root 3. And so, of course, this triangle is congruent to that one as well. So this will also be 3 root 3. And so that means the entire base is 6 root 3. And the area of a triangle is 1/2 base times height. So we're subtracting 1/2 times the base, which is 6 root 3, like we just said, times the height of 3, because the height is perpendicular to the base. So this entire thing ends up being 36 pi over 3, so that's 12 pi minus 1/2 times 6 root 3 times 3, which is 9 root 3. But remember, that's not our final answer because we only found half of this. Remember, we have to multiply it by 2 to get the whole shaded region. So that'll become 24 pi minus 18 root 3. And so we have our answer in the form a pi plus b root 3. So a is 24, and then b is negative 18, and then c is 3. So we get 24 minus 18 plus 3. So our final answer is 9. So, yes, this was a little challenging, but I think that these types of questions are so, so, so cool. So, hopefully you found this pretty interesting as well.